With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A brass wire 2 meter long at 27 degrees Celsius is held taut with negligible tension between the two rigid support. If the wire is cooled to a temperature minus 33 degrees Celsius, then the tension developed in the wire, its diameter being 2 mm, will be. So if you see here, when it was having this temperature, 27 degrees temperature, then the tension was negligible. There was no tension. And when the temperature is changed to this, what will happen? The string will try to contract. If I say this is the string and this is fixed about both hand like this from the rigid support. So what will happen when it will when you will decrease the temperature of this, then it will try to contract, but it will not get enough space to contract, right? It will remain elongated. Because of that, the tension will be developed here, right? So let's see how much tension will be developed. So if you see here, I will write down the stress is equals to Young's modulus times strain. What could be the strain? If the string wasn't fixed about this both end, then what could be the result? It may expand whatever amount it wanted to expand, it can expand, but now it is fixed at both end, so it is not getting enough space to it is fixed about both ends, so it is not able to contract itself. So here the stress will be developed. So let's say the tension developed is T, so I will write down T by A is equals to Young's modulus times strain is change in length by original length. So change in length you can write down, we know that if we decrease the temperature, the length will try to decrease, which will be proportional to the initial length change in temperature and linear expansion coefficient. So if I divide both sides by L, you will get the delta L by L value as this. You can put this value in this expression. So I will write down tension per unit area, that is the stress, is equals to Young's modulus times alpha delta T. We want the tension. So do one thing, just make this tension T naught so that we could differentiate this temperature with the tension, right? So if you see the temperature, now we can see here it is T naught is equals to Young's modulus area thermal expansion linear thermal expansion coefficient change in temperature, right? So if you see here the diameter is given, you can calculate the area, and if you see the change in temperature, so earlier the temperature was 27 and you decrease the temperature to 33, so how much you decreased? It will be 27 plus 33, right? So let me write down the change in temperature. It is final, that is this, minus initial. So change in temperature will be the same for if you calculate for degree Celsius or Kelvin, because the division number of division is 100 for both, right? So this is the 60 degrees Celsius is the change decrease in temperature. Length is 2 meter, which is not required. You can get the diameter. If you see, you can write down the radius of the wire. Radius of the wire will be 1 mm, that is this meter, right? The linear expansion coefficient is 2 into 10 to the power minus 5. Let me write down this. So if I write down the Young's modulus, it is 0.91 into, it will be 10 to the power 11 into the thermal expansion coefficient is 2 into 10 to the power 5, that is given in the question. Area you can write down, it is pi r square, and r here is 10 to the power minus 3, so it will be 10 pi into 10 to the power minus 6, right? So let me write down the area. So change in temperature, decrease in temperature is 60 degree. So this will be the tension. You can now multiply this. So if you multiply it, you will get approximately 340 Newton. This 10 will be 1. If you see 10 to the power 11 minus 11, it will be 1. Now if you see, the correct option here will be C. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.